Hi everyone, welcome to my channel. Let's learn the algorithm together. Today we will take a look at the 10747 remove all adjacent duplicates in string. And we'll be given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and then remove them. We repeatedly make duplicate removals S until we no longer can. And then we return the final string after all such duplicate removals have been made. And it can be proven that the answer is unique. And now let's take the first as example. Like we have this string like A, B, B, A, C, A. And then how we will start to work on them. For example, like we have two exactly the B, right? Let's copy one. And then we can remove the duplicate B at first. And then it means that now these two A already adjacent, right? So we can then remove the 2A. At last, we only remain like have CA. So then we return CA. And next example is AZ. This one, AZXX ZY. And it's the same, like first we remove the double X, AZZ, it turns out to be AZZY. And then we remove this 2Z, and it turns out to be AY. So we return AY. Now how we will remove these duplicates. At first I will definitely say like probably using two pointers, right? When we are go through the whole string, and probably it can help us like, for example, we can still have the first one as an example, like we have two pointers and help us to find any like duplicate numbers, or we turns out it to be like array. And when we find these two duplicates, we can remove the letter, the following characters ahead or something like that. But that will be really inefficient, right? And now probably, let's say, so now if we are just using like one pointer to go through this whole array, and I will just find a box here. I love the box theory. Here, the box. And I will put like the first letter I saw is A into it. And then I find the second one is like B. And then when I go through the third one, it's still B. And I found that like the previous one is also B, right? It means that these two can be paired out. So how I know that the previous one is just exactly what I want, and because the order how we put the things into it, and we can always check the previous one, like in this box is the top one, and then if they are the same, it means that I can remove the top one out. We cannot like remove the other nodes. We can just only remove can compare with the top one. So here there's a characteristics is like the nodes is last in, but first out. The first out means once they match, they have to go, but if not, they can continue to stay here, right? And now we are seeing the B here. And we can like remove B with the current one. So now we probably can know like what kind of this box it is. We can say this box is just a stack. We are using a stack to help us to deal with these letters. And now continue to move forward. And we have A and A, because now the top one is A now. So exactly the same. We can say that. Let's make it smaller so I can write down my ideas. So now, like, when we are go through the character in the string, once if the current character is equal to the stack top one, right? It means that we can like delete both of them. So we just remove the stack top. And now we are seeing A again, so it means that we can remove it. The previous one is B, we also remove it. And now we move to next one, C. There's nothing in the stack. And also, it means that if there's nothing in the stack, we don't have to like compare it. So here's another condition is like, if the stack is not empty, then we can compare it, right? And the current chart is also equal to the top, then we can remove it. Otherwise, we just push the current character into the stack. So now there's nothing in the stack, we push C again, and now we are moving to A, and A is not equal, it doesn't like match this condition, so we continue to put A into it, and now we are already done everything into it. So now we can use a string builder. And then we are like go through the chart in the stack and start to build a character, right? So now it will be like, let's say first, this is the stack and this is the steps. And when we go through every character in the stacks, we can start use the string builder to append this character. And after that, we can just return the string. This is what we want. Right. So now this is the whole step, and let's go through an example to validate it. And we can continue to use this one. A, Z, X, X, Z, Y, right? And first of all, we go through the character in the string. So it'll be like, we have A now, and nothing in the stack. So we will go to these steps, put it into the stack. So put A into it, and then we start to move the pointer to Z. So the stack's not empty, and current chart is not equal to the stack. So we go to this step and put the current Z into it. And now it turns out to be like, we have Z now. And the next step is like we meet the x, and when we meet x, so it continue to meet this condition, we put it into the stack x, and now move to next one, and now we see x again, and also the stack is not empty, so it meets this condition. It means that we need to remove the top, and as I said, like yes, it's z, so we have to pair them out and move to next position in z, and then now the stack is not empty, and also the current char is equal to top to it. It means that we are also need to remove it, z, and then move the last one, y. Even though the stack is not empty, but the current char is not equal, so we go to this step. It means that y have to put it into it, so it will be y here. And now we can start to go through the stacks, like the char in the stacks, and we can append the char into it. So we append a and y and then return it. That's the whole steps now. And what is the time complexity? Because we only like go through the string like for one time, so we use on, and means the numbers of the length of the string. And how about the space? So the space is because we are using a stack, and the worst case is like every letters in it they are just different, no duplicate letters. So the worst case will be on, and means the numbers of the string. I mean the length of the string. So that's pretty much now. And now let's move to the coding part. And as I said, we have to have a stack first, and what we put inside it is character here, and then equal stack. And now we start to go through each letters in the stack, in the string, and to char array, right? And then if the stack is not empty, we can start to compare it, and the current char is also equals to the stack top. Then we can pop out the top, else we can just push the character into it. And after we go through all of them, we have a string builder to help us to build a string. And for go through the stack, we don't have to like pop it out every time. We can just use the for like char here, and this will help us to go through like also from the bottom to the top. And if we use the pop, we can go through it from the top to bottom. So now how we build this string is from the bottom to the top. So that's why I just use a for loop. And now the builder dot append char, and after append that, we just return the builder dot to string here. And now let's run it. Oh, so yeah, we don't have this function, so just use echo now. Cool. So now test case is passed, and let me double check if there are any corner case, like if the string is 0 or none, and I think there's no because strings at least have one, but of course you can have always to check like this, none or s dot length equal to 0. We can just return like an empty string, and let's submit it. Great, so we pass all the test cases now. So from this problem, we learned that if we want to like move something duplicate, and especially they are adjacent, probably we can use a stack to help us, because the top of the stack is always the previous, or we can say adjacent letters just we go through, and that's how we solve this kind of problem. If you think this video helps you, please give me a thumbs up. That would be great encouragement for me. And thanks for watching. See you at next video. Bye.